Okay, hi guys. Welcome back to Physics 145. Today we're going to look at chapter number 3. Okay. So chapter number 3 will be linear kinematic. So linear kinematic is talking about the study of acceleration, displacement, velocity, okay, and so on and so forth. By assuming the object that we study is dimensionless. That means the size, the shape of the object is not important when we talk about their acceleration, their velocity, and their displacement. Okay, it's just like they are called dimensionless. You can assume them as point particle. It can be a car, it can be an aeroplane, it can be you, it can be a frog, it can be a stone, it can be a ball, anything. Okay, we can assume them just like a simple particle. All right, so that means the shape and the size is relatively not important. Okay, relatively not important. So in our linear kinematic, our 3.1 is talking about displacement, velocity, and acceleration. Okay, and also acceleration. So the first one will be our displacement. We look at our first one, displacement. What is displacement? Before we need to look at displacement, there is one friend of displacement, which we will call distance. Okay, so first look at distance. So what is distance? So let's assume you have 2 points. Okay, two town. Okay, two town. Town A. Okay, this is town A, and then we have town B somewhere around here. Okay, town B. And then there is a road connecting town A and town B. No other road, there's only one road. So that is the road connecting town A, go down to this direction, and then go up again, and then go further to avoid some hill and river, and finally end up in town B. So this dotted line is a road used. So now let's say you are walking from town A to town B, you have to follow the road. Okay, because it's all jungle, unless you want to pass through jungle, no problem. Okay, so let's assume you are walking or you are driving, so you have to follow the road created. Well, they built the road like that is for a certain reason. Maybe they need to avoid a mountain. Okay, the mountain is here, and then there is a lake. Okay, so mountain and lake, these are areas that is difficult for people to build tunnel. Okay, to build tunnel under the mountain, and also to build a bridge. It's not to say impossible, it's just that it's going to increase the cost. So they try to avoid that, so it's making the road become zigzag or any pattern that you can imagine, but depending on the geographical information in that location. So this, if you follow exactly this dotted line, so this one we will call the distance. So that means distance is the total path. Okay, total length of the path taken. Okay, is the total length of the path taken. You follow every step on the road that you use to reach town B by following the road. That is your distance. Distance most probably is the longest way that you have to use, okay, to get from one place to the next. So now next one is, let's imagine instead of using the road, now you bought a helicopter. Okay, so your helicopter can actually fly from town A to town B in a straight line. Okay, in a straight line. So that straight line will be from A to B directly. from your house helipad where the helicopter can land, and then you land on another location like the top of another building, maybe your office. Okay, so this red color dotted line is the shortest possible path between town A and town B. So you are flying, your helicopter is flying in that direction in a straight line. So let's assume we are talking about from A to B. Okay, from A to B. So this is a one-way movement from A to B, and you see it's a straight line. Why we can do that? Because your helicopter is flying. Unless you want to, you are so less intelligent that you have a very humble IQ, you fly your helicopter following the road. Okay, well, that is not very intelligent. Anyway, the purpose of this flying machine is to avoid those problems. Okay, so this one we call displacement. Okay, displacement. So displacement is what? Displacement is the change in position. The change in position. You are in position number A. Now after the displacement, you are now in position number position number B. So our displacement can be defined as, okay, is defined to be the change in position. So position normally we refer to coordinate system. So let's assume that this position here is x1, y1, and this one is x2, y2. Okay, x1, y1 to x2, y2. So that is the position. How we use position? Assume the surface is flat because you are studying two-dimensionally. So the height, the z1, z2, we forget about that. Okay, so that is the displacement, change in position. Okay, is defined to be the change in position. Of course, when you say change in position, you don't have to mention in the shortest possible path within a specific direction. That is a Form 4 definition. You're not in Form 4 anymore. You are in diploma, and you have to use much more powerful definition. Okay, much more powerful definition. All right. So displacement is defined to be the change in position. So our formula for displacement and our symbol normally for displacement will be S, and it is a vector quantity. Okay, it's a vector quantity. So our displacement, okay, is given by the change in position. So normally that will be equal to position number 2 minus our position number 1. Okay, position number 1. Okay. So why we write something like this? Okay, why we write something like this? Well, the reason is why we have displacement 2 and displacement 1. So the reason is this. Now again we draw another coordinate system here. So I draw it here so that you know what is actually happening. Why we call the change in position. Okay, so now we're going to this is our y and x here. We're going to transfer this diagram here. So now our town is here. This is town A. Town A has a coordinate x1, y1, and then our town B is here. Okay, town B is here, and our B is x2, y2, and our origin is here. Now we have two vectors involved. Okay, we have two vectors involved. One is this vector. This is our S1. See? S1, initial position. You are here initially. Your helicopter is here. And then followed by another vectors. This one is our S2. Okay, our S2. This is your second position vector. This is the displacement vector for B. Refer to this position. This is vector displacement vector for point A, referring to this point. So your vector S is from A to B. See, from A to B, this is your displacement from A to B. So your displacement, how do you go there? This is your initial point, okay? This point is your initial point, and this point here is your final point. So to move from initial point to final point, okay, we are using this, our S here. So to move from here to here, there is another method. You can actually move from I, go to origin, from origin go to F. See, your location will be from I move to origin. And then another one is plus from origin go to F. Okay. So what is your vector for moving from I to origin? The opposite of S1, right? So is negative S1. Plus from origin to the final point is your vector S2. So because of that, we move this one to the side. It becomes S2 minus S1. So this formula is exactly what we are talking about here. Okay. So that is the one we are referring to. Okay. Change in position. Okay. But of course, you don't have to know this detail, but it is good to know something like this because this is your foundation. You are engineering, whether you are civil, electrical, mechanical, basic is one of the most important. So I don't want to teach my student without knowing the basic, but they can get very good marks. Well, that is something very ridiculous. Sometimes we don't know what happened. Okay? Alright, so that one is in 2 dimensions, you see. But if your motion is restricted to horizontal motion, then, okay, for horizontal motion, normally we refer to X, okay, X, normally refer to X axis. So your formula for displacement will be X2 minus X1, okay. For example, you are moving horizontally. For example, this is our horizontal x-axis. You are moving from 4 to 8. These two locations, 4 to 8. Your displacement is in this direction, from 4 to 8. So that means 1, 2, 3, 4. 4 centimeter only, okay, to your right hand side. If you move to the left hand side, that will be negative already. Okay, so that one is horizontal motion. And then for vertical motion, we are referring to the y-axis. Then your formula will be y2 minus y1. Okay, y2 minus y1. They are the same concept, except now you are referring to vertical motion instead of horizontal. That's why the Cartesian coordinate system is important. All right. So now you have your displacement. So sometimes we can simplify this one to become delta x, changes, okay, changes, and this one will be delta y. All right, delta x means changes in your x. Changes mean the final point minus the initial. This is your final, this is your initial. Delta y is your final y minus your initial y. All right, so that is the displacement concept. Okay, so in short, displacement is the shortest possible path between any 2 points and then in a specific direction. Okay, but in your definition, you can also give displacement is defined to be the change in position in our coordinate system, Cartesian coordinate system. Okay, now next one is our velocity. That is number 2. Okay, number 2 is our velocity. So what is velocity? So velocity have a symbol U or V, but here we use V first. Okay, is defined to be the rate of change of displacement. Okay, the rate of change of displacement. So the rate of change of displacement, meaning that your V is equal to the changes in your displacement divided by changes in time. We call this one time interval, alright? But it also can be written down something like this, okay? Something like ds dt. But ds dt is in a calculus form, so this one is a more complicated situation than the velocity by itself. So normally we don't use this one at the moment because in your situation, your physics 145, normally we don't go up to that detail. So we use this one. So that means you have changes in your displacement divided by the changes in time. But this one, it still depends on whether you are horizontal or vertical. So let's say you are in a horizontal motion, okay? For horizontal motion, for HM horizontal motion, your changes delta S, your S is in the x2 minus x1, okay? So your Vx in the x direction is given by changes of x divided by changes of time. So normally refer to x2 minus x1 divided by your time t2 t1. If it is for vertical motion, then your Vy is going to be delta y over delta t, which is y2 minus y1 divided by t2 minus t1. Alright, so that is the velocity's concept, okay, the concept of velocity. And since velocity is defined as the change of position, so velocity is also a vector quantity, okay, it's a vector quantity. So these are all vectors. So when I write x like that, y like that, so it's referred to vectors because this coordinate change in position, they are all displacement, they are vectors. Alright, so what is the unit for velocity? The unit for velocity, SI unit is meter per second, okay, meter per second. But we can also use some other units which is not very famous, like kilometer per hour. This is the unit we use in on our Malaysia road, kilometer per hour, because if you put a signboard saying 90 kilometer per hour, the limit, speed limit, well, it's quite easy to understand. But imagine that you put 90 meter per second. You know how fast is 90 meter per second? 90 kilometer per hour is roughly 25 meter per second. You're 90 meter per second, you're driving a helicopter already, okay? So that one is not something that is very commonly used in our on our road signboard. Alright, so because not many people are learning physics like you. Alright, so that is our velocity. Next one, okay, next one is acceleration. Acceleration have a symbol A. So our acceleration, we define first, is defined to be the rate of change of velocity. How your velocity change, okay? So that means our A is equal to velocity like this, changes in time, okay? So what do we need here? If you have a change in velocity, that means you're going to have initial velocity and also final velocity. So that means our formula, we can change it to something like this. Final velocity minus initial velocity divided by time. Okay, divided by how long does it take for this one to change. But in our diploma level, our symbol for final velocity is V, initial velocity is U, and the time is T. So that is our formula for acceleration. Okay, and this one is the velocity. But remember, we have two changes here. So acceleration is also a vector quantity because it is defined based on the change of velocity. Now, the unit for acceleration is meter per second, or we can also use something like this, which is very uncommon. Okay, very uncommon. Kilometer per hours. Okay, so normally this is a very big unit. Normally the value here is very small. Okay, so just bear in mind our SI units for this and this one. Okay, so the only difference is a -2, this one -1, so it's very easily confused. Okay, now since you already have all this basic thing, okay, you already have this basic, so you look at the summary here. Summary for the first thing we have done is we have displacement S, and then we have velocity V or U, and then we have number 3, we have acceleration, which is A. So in physics we want to know the relationship between them. Okay, the first one actually we can already get from this equation here. If you look at it carefully, we multiply them, you're going to get this V equal to U plus AT. See or not? I think this is very familiar to you in your Form 4, your chapter number 2. When you study kinematics, this thing also come out. And the best part is in exam they give you the formula right in the appendix. Okay, but now it's no more given. Okay, no more given. But when it comes to online tests, I can consider not given. Okay, but you know it by yourself lah. You can open one of the computer and look at you taking your test, and then you have another computer doing something else, another playing game maybe. Okay, so the next part that we're going to look at is 3.2, which is the combination of all this one. We call that one kinematic equation. Okay, kinematics equation. We have all 4 of them. We are not going to derive that. Okay, we're not going to derive that. I'm going to give you all that 4 equation. Number 1, okay, is V equal to U plus AT. Okay, final velocity, initial velocity, acceleration, and time. Okay, and then the next one, number 2, is V square equal to U square plus 2AS. Final velocity, initial velocity, acceleration, and displacement. Okay, and then number 3, we have this S is equal to UT plus half AT square, displacement, initial velocity, time, acceleration, time square. And the last one, we have S is equal to half U plus V times T, displacement, initial and final velocity respectively, and the time. So these are the 4 equations that you have to memorize. And you see, each equation there we have 4 parameters. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. To know one of the value, you need to know 3 other values. Okay? So, to use this, we have assumption. Okay? All this can only be used under constant acceleration, constant A value. Okay, constant A. If your A is not a constant, you cannot use this equation. Okay, that is the one, of course, one of the criteria. All right. So we are going to look at some of the problems, example on how to use this. Okay, so that will be under solving problem in 1 dimension. All right. So this is page number 1. This is number 2. Okay. So come to page number 3. That is 3.3 application of kinematic equation. Okay, application of this kinematic equation. Right. So we start with example 1. Okay, example 1. Let's say a car. Okay, a car moving with velocity of, let's say, 25 meter per second. Okay, a car moving with velocity of 25 meter per second suddenly slam on the brakes. Okay, slam on the brakes and come to a stop. Okay, suddenly come and slam on the brake and come to a stop in let's say 35 meter. So that means after traveling 35 meter, it stops. Okay, so calculate the acceleration of the car. Okay, the acceleration of the car. Alright, so of course you can use the kinematic equation, that's the purpose, but you have to assume that the acceleration of the car now must be uniform. You cannot change anyway, it must be uniform. Okay, so we start by drawing a diagram, a simple diagram. This is a car, okay, on the road, and then it is moving with initial velocity u equal to 25. Okay, and then it come to a stop. Okay, come to a stop in a displacement of say 35 meter. When it come to a stop, your v is equal to 0. Okay, now find the acceleration of the car. So what is our formula? You have v, you have u, you have a. You need to find this. Now visualize. You have v, u, a, s. So that is equation number 2. Okay, equation number 2. So from number 2, v square equal to u square plus 2as. So final velocity 0. This one is 25 square plus 2a and multiply 35. So what do we get here? See, we're gonna have this 25 square divide by 70. Okay, and we're gonna get negative, right? A equal to negative 8.93, and the unit is meter per second per second. All right, so the value is huge. Okay, and it's negative. It means that the car is slowing down. Okay, slowing down. Well, in this case, it got nothing to do with the direction. It's a slowing down process. Your velocity is reducing. So what happened to you is when you are driving and then suddenly you come to a stop, your whole body, if you're not wearing any you're not wearing seatbelt, so you know what happened next, huh? You're going to kiss your steering, and finally you end up kissing the windscreen. And if the windscreen is not strong enough to handle your kisses, finally you end up kissing the tree in front of you. Alright, so that's why seatbelt is important. Okay, seatbelt is for your safety. It's not for the police, okay, to see. Alright, so that one is the first part. Calculate the acceleration of the car. Now, using the same example, calculate the time taken to stop. So I will call this one A, this one B. So calculate the time taken to stop. How long does it take from here to reach here? So again, you have V, U, S, and you want to calculate the time T. The T also we don't know. So now, what information do you have that allow you to use T? Because we already calculate A, and you have V, you have U, you have A, you want to calculate T, we use this equation, V equal to U plus AT. Okay, so the V is 0, the U is 25 plus the A is negative 8.93 and multiply by T. So we have this, just simply divide 25 divided by 8.93. So it's going to take 2.80 seconds. Okay, 2.80 seconds. So you see that? Okay, so that is the time taken. It's a very short time. Okay, to come to a stop in about 3 seconds like that. So it's one of the important things to save your life is the seat belt. Okay, is the seat belt. All right. So these are example of kinematic equation. Okay, example 1, talking about car. Now come to example 2. Okay, example 2. Now let's say example 2 we have something that is accelerating. Okay, something that is accelerating. A plane, aeroplane. Okay, a plane can accelerate. Okay, a plane can accelerate at 2.20 meter per second from standstill. Okay, on a flat runway. Flat runway. Alright. Now, if the takeoff speed is let's say 38 meter per second and the runway is 250 meter long, the question is, can the plane take off safely? That means, can an aeroplane take off, or the runway is enough for the plane to take off? So we assume the plane is standing still and then accelerate 2.20 meter per second until it reach 38 meter per second. Then it will fly. Takeoff speed. Takeoff speed means it need to reach this speed before it can fly. Okay. So we write down what we have. Initial velocity 0. Final velocity, it must reach this velocity 38 meter per second to fly. Now your acceleration, the acceleration of the plane is 2.20 meter per second. This one is for us to compare. Okay, the runway is 250. We want to know whether this plane can fly enough runway to fly or not. So we need to calculate the displacement. So now you see that we have UVA. We want to find S, so we use this equation. 2AS. The V is 38 square. U is 0 plus 2 times 20 multiplied by S. So we calculate the S value, see whether enough or not. 38 square. Okay. Divide by 2. Divide by 2.2 again. We have 328 meter. Okay. So the plane will need 328 meter to reach that takeoff speed. The runway is only 250 meter long, so that means definitely is not enough. Okay, definitely is not enough. So the runway is not long enough, okay, for the plane to take off. Sorry, your plane just simply cannot fly. You are short of how long? 328 minus 250. So you're short of about 80 meter. Okay. So that is one of the application for using kinematic equation. All right. Okay. So that is 3.3 application of kinematic equation. So The next video will be on our application of this equation in vertical motion, okay, under free fall, okay, under free fall.